market platform, and today we're going to be talking about blockchain for distributed design and urban manufacturing. So the distributed design market platform is a four-year Creative Europe funded project, and is looking at the emerging field which has come about through the maker movement and the digitization of the design field. And what we're interested in is researching culturally and also politically and also technically what arises in that field. And we're specifically interested in the relationship between makers and new markets. So today that's pretty much where we're going to focus a lens on this kind of emerging field of blockchain as an enabler for this new conversations around how we manufacture through distributed design in our cities. So we also have an online community which is dedicated to this project. And through this online community, we facilitate with 12 partners in Europe events and resources and ideas and conversations which can kind of facilitate this conversation of makers and new markets. So if you are interested in this field and you're interested in being involved with our 12 partners, we have different kinds of events which all come online, and you can see them. And in saying that, today we will have part of this very event distributed live online. So we're kind of at the whim of the technology gods slightly. So at times we may have to just bear with the technology, but at the same time, this is what we're all here for, is to make this technology work for us in a better way and make our lives more enriched by the way that they can serve and it can serve us. So without further ado, we will introduce the first of our speakers. Yes, so platform ecosystem for distributed design. Tomás Diaz, who's joining us from FabLab Barcelona, he's the director there, and he will join us to speak about the concept of why we're here and how platforms and blockchain enable this form of distributed design. Following that, we'll invite Tom Salfeld from Wiki Factory, who is joining us all the way from Madrid, who will talk about collaborative design and manufacturing. And then after the break, we will move into our discussion panels. Here live for the discussion panel, we have Karen van der Meulen, who is joining us from VARC in Amsterdam. And we will also invite some online speakers who Tomás will introduce. So welcome and thank you so much for joining us. And please come and see us if you would like to talk about distributed design market platform.
Thank you, Kate. Good morning, everyone, and apologies for the slight delay. As Kate say, we are a little bit entangled with the limitations with technology. I will try to be fast. As introduced, we're going to talk about the platform ecosystem for distributed design and manufacturing. We are in the verge of a big transformation, but also in the convergence of many technologies. We are going to speak about that later on with Jamie and Primavera, how to tackle this important moment in time in which not only the digital world is in our hands, but actually is starting to move also into the economic process related with how we produce and consume, right? This is not a trivial aspect, a trivial transformation. We're seeing how AI, blockchains, synthetic biology, 3D printing is more accessible for everyone. The question is how we are going to organize an emergent society around these technologies. So these are the kind of questions that we are putting on top of the table. They might sound like big questions, but in order not to be only theoretical, we're going to illustrate them as well through some examples. No? I want to start with a short video, and then I will continue. We need sound. Hopefully, we go back. Maybe sound will go out, and probably I need to do this. I'm sending sound through HDMI. So it should work. Okay. Let's hack it with the other cable because HDMI is not being sent. Cable is connected, and now I am going to check that I'm sending sound to that cable. Yes, I'm sending through that cable, and I'm going to play it now. It's going out. You think it's my audio? I can check that. It's not mute. I can refresh. Technology is very... I can try again. I can try without. You're right. We're not sending audio. Let's try something live, which is trying to see the hack. And I'm gonna go here. There's no sound being sent at all. That's interesting. Okay. So I'm going to skip this video, which try. Oh no, it's like about the music. So I will kill the whole thing about the video. Okay. So after what we're talking about, and I'm going to pass it basically without audio. We're talking about this, the paradox of the convergence of technology, meaning like, you know, when we have the capacity of redefining the relationships under which we have organized society and reconfiguring these connections, the question is like how we're going to do those, right? How we're going to basically put, you know, artificial intelligence to work for us, autonomous robots to being able to take the decisions that are on the benefit of humanity, or how we actually avoid of all this massive transformation to go against us. We have a recent example. It's basically what has been happening with the internet. It's like how we have accumulated the computer power in the hands of a few. The question is, if we are going to have access, or if we're going to have like a more massive access to the production means, the question is if we're going to concentrate those as well in the hands of a few. So again, this the recent transformation has been very rapid. Like we have moved from storing computers in rooms like this size to actually have like supercomputers in our hands. We are hyper connected with the rest of the world. We are able to send information very fast, anywhere, anytime. The thing is that, like, again, under this new paradigm, we have moved from having, you know, you can compare this, make an analogy of how television worked, you know, in the middle of the last century, which is under a centralized model. You know, there is one broadcaster and many consumers, and now you can basically, we are streaming now. We can become a television channel. Anyone can be a television channel. It means like, you know, it's more like a non-hierarchical relationship, decentralized or distributed relationship. The question is how we take it to, imagine like, as it happened in the digital world, we take it to the physical world. Meaning like, with the rise of the access of places like this, or Fab Labs or maker spaces around the world, you are not only going to be able to become a television station, but actually you are going to be able to become a mini factory. And the question is, how, you know, if we have organized the current economy based on the limited access to the means of production, and therefore the creation of distribution channels, supply chains that are very limited. What happens when this is accessible for everyone? And this is what has been happening during the last few years. These graphs show the growth of these kind of places in the last decade. Fab labs are spreading around the world. Inside each one of these dots, you can find these processes that combined can be used to make almost anything, right? Right now, if you design something in Tallinn, you put it in an online repository, it can be downloaded in Lima or in Cape Town or in Wellington, and can be reproduced there without having to use a shipping container, without having to fly atoms through the world. So inside the things that are being reconfigured, as I said, are related to many fields. How we're going to design fashion elements, or how we wear what we wear, right? Industries that seem to be very well established are starting to be disrupted by basically the simple fact that people is having access to these production means. And I'm not only talking about a 3D printing clothes, but actually being able to have industrial knitting machines in places that are closer to where those products are being consumed. And that happens with all, as I said, with other fields. This is an open source restaurant, for instance, that you can download completely and reproduce anywhere in the world. It's not just a tiny design of a 3D printed Yoda, but actually I'm talking about entering into the IKEA market in terms of how furniture is being produced inside cities. Housing market, maybe I'm kind of a little bit, how do you call it? I'm not completely convinced on the idea of anyone can make their own house, but at least this shows just the type of scale of the type of things that you can do in some of these manufacturing spaces, right? Drones, as I say, autonomous vehicles that are actually you can decide which is the autonomy that those vehicles are going to have, and you're not just have to buy it off the shelf and use some kind of design algorithm by someone else. Systems for growing food. In this case, this is an aquaponic system, which basically create a circular system, a circular kind of cycle in which fish clean the water of the plants and give nutrients with the poo. Actually, it's the other way around. The plants clean the water of the fish eat food, they poo, and they feed the plants, right? So you basically can design the taste of a plant based on what you feed to the fish. So, and also by the frequency of light, the LED lights that you put into the plant. So you are able, in a way, we're talking about a programming food. And it's not only in the field of aquaponics and the more kind of a traditional agriculture, but actually think about how we can program, for instance, the growth of meat instead of having to kill animals to consume this type of proteins. No? But the same type of processes we use them to make, another example, beehives that you can embed sensors inside and start to monitor what's causing the colony collapse of the bees, sensors to measure pollution in cities. This is a project that we have developed in our lab in Barcelona, which is called the Smart Citizen. These sensors combined with larger, low-cost sensors with more professional sensors can be used to track the pollution in cities, which is a big issue today, especially in Asian cities. But also we have seen that cities like Madrid and Barcelona are suffering very hard about the air pollution thanks to traffic. And in Barcelona, thanks to the cruise ships that stop to bring tourists into the city, right? So these some of the examples are projects that have a physical, let's say, element, but also have a highly digital component. In this case, when you make something with a 3D printer, you are turning digital information into a physical object. When you use a sensor, you are turning a physical manifestation particles. You are counting particles. You are turning them into a digital information. So it's this kind of a fluid relationship between the physical and the digital that are kind of stimulated with the access to these digital fabrication tools. So the question is how we're going to reorganize. Again, as I was saying, the the fact that we're seeing like, this is kind of the early stages. It's comparable with what was happening with computers in the 70s, right? The computers were really like a geeky, very, I don't know, they were doing like a very simple stuff. That you have like just lights, and they were showing like a pattern, and there was like a kind of magic turning on and off an LED, or in controlling how an LED will turn on and off. We're more or less in the same time in which we're making things that they don't look yet like finished products. I agree, but they're far more advanced than the computers were in the 70s. So we strongly believe that we need to start to think how are gonna be the next 40 years ahead, right? And then how we're going to combine again all these or the convergence that we have today that has been constructed from many processes decades before, but we believe definitely that should be sustained under open source collaborative values. Meaning, like if we build the industrial paradigm based on limited access to the means of production, competition, intellectual property, etc., this new production paradigm should be built under different values in order to be more accessible, more open, and again, not I would say like contributes to the two main issues that we are having today. First one is the massive devastation of environment that we are causing thanks to the exploitation of resources under extractive economy. And second of all is the kind of the social consequences that we are creating by limiting more and more, like basing our economy on the administration of scarce resources, basically. We're talking here about abundance of resources, how we organize the world under the idea of abundance of resources. So in DDMP, this project that Kate was mentioning before, we're not only promoting makers and designers around the world, but actually we're bringing another dimension to the mix, which is how we stimulate the exchange, how we bring when we say bring makers to market, it doesn't mean to try to bring these makers to the same market that actually we know that's going to fail. So it's not about like bringing makers to the Silicon Valley paradigm. Like grow a super startup in 2 years, try to get an exit of a few million euros, run away and get investment going and trying to maximize your profits, right? Which as the only goal. Is what we are trying to do is test, give us the opportunity to test new forms of combining the capacities that we already have. So if we have 1,600 Fab Labs and probably a couple thousand maker spaces around the world that are providing the access to these tools, and people are making and developing projects at the small scale, how we bring them in into a market that again is not selling to Amazon, is thinking about how we create the market itself. Okay, so some of the work we do is based on going to events, organize events like this one, also go to maker fairs and all the related events, and trying to promote the talent around, especially around Europe, but also around the world, and connect, and create a community around these practices. But we are also creating a platform ecosystem, as I said before. For many years, we have been developing the FabLabs.io platform. This is where Fab Labs, when they become official part of the network, they register themselves, they go through a peer-to-peer review process, and they are added to a list of Fab Labs. This is where you can find the 1,600 Fab Labs that are today in the world. And you click in each one of these places, and you will find that they are machines, there are people behind them. There is physical infrastructure with a space located in somewhere in the world, and there is people behind these machines and running this space, right? For some years, we have been trying to develop projects, no? And I'm sorry, like actually, yes, that's a dildo. That's an open source dildo that one student from Sweden developed. So you can download and make your own sex toys, for instance. No? So apart from that anecdote, what I'm saying is like we are opening up the capacity for anyone to share their projects at any time. But we have limitations. There's people doing this work better than us. People like Tom and his team in Madrid. Tom is gonna talk to us about how they're doing it in Wiki Factory. So we are creating this platform ecosystem, right? So we're getting some European money, which come from your taxes, and then Tom has been working very hardly on developing Wiki Factory with his team, And then we can come and use your taxes to develop yet another platform and kill the initiative of Tom. That's what you will use it. You will do it, normally. It's like I'm going to create the next platform. So instead of that, we're taking an ecosystemic approach to this idea of developing platforms, because it's not only Wiki Factory that is developing amazing tools for makers to develop and share projects, but it's actually this other platform which is called MakeWorks. We just actually acquired, allows also go beyond just the maker spaces and Fab Labs, and basically show the capacity that you can find in each city for industrial production. In this case, this is an example in Scotland where MakeWorks have been doing a very, very, I would say, artisanal work on trying to document and register the local capacity for manufacturing. So imagine that you have the Fab Labs where people learn and prototype, platforms like Wiki Factory where people share their projects around the world and they can do collaborative development. And then you have the mapping of a local manufacturing ecosystem, which actually you can use to do small batches of production on demand. So these things are not connected at all. And that's where we want to work. But when we think about a platform ecosystem, it's creating a platform of platforms. Sorry, that's... So this means that this is connected with this idea of rescaling manufacturing. And this is where Industry 4.0, smart manufacturing, advanced manufacturing, you name it, comes in. So you can have, what we think is like this ecosystemic approach connects from individual 3D printers in your house to large manufacturing facilities in regions and in countries. So the thing is like we don't have connection between these. Somehow they are kind of isolated. And the kind of the challenge that we put ourselves to do is like how we stimulate the relationship between all these scales. How do you go from maybe 3D printing in your house, something that broke in your glasses, maybe the sole of your shoes, something breaking, like Whirlpool is doing, that they have released a database of their 3D printing files of some of their products. So if something breaks, you can 3D print it on demand in your house. But then probably you cannot make in your house a piece of furniture for your apartment, or you cannot learn certain things. So basically you go to a Fab Lab, and then you can learn. You can actually make bigger things that are one-offs. But what happens if you want to start to sell some of your designs to someone else? Probably a Fab Lab is not the right place to do that. So you need to have access to a small manufacturing facility. And then probably you need to have access to a more complex and more advanced manufacturing process. And then you go to a larger industry and so on. No? So we start to think about this kind of rescaling local manufacturing or recalibrating it and trying to avoid, for instance, import plastic cups from China, which actually is something that happens very, very frequently. So, but this ecosystemic approach, again, needs to be somehow taken down to the city. And we're going to talk later today and tomorrow as well in a related event about which are the implications for cities on creating these conditions for local manufacturing, right? What is this is what we're doing in Barcelona, for instance, which are the implications for neighborhoods and how we can start to testing neighborhoods, how these new relationships between manufacturing, design, waste, and so on are reconfigured under this new notion of distributed design, right? Again, in the linear model, which we have been exhausted for the last almost a couple centuries, we have very separated processes of production, distribution, design, et cetera, and then we basically have a very clear relationship between the design, creation, production, distribution, consumption, waste. And the question is, how can we reconfigure these relationships? They will start to be not that linear. They probably are not going to be that circular. They probably start to become spiral relationships, or more going from a mechanical kind of a point of view to a more quantical point of view. So this is idea of what we call also as well, like what type of processes, design processes, will imply doing this. And this is what we call also the being able to design emerging futures, meaning like when you have the knowledge and the capacity and the access to these tools, these prototyping tools, you can start to develop new approaches to production of energy, foods, clothing, health, anything that you can imagine in cities from a different perspective, and you can create different. You can start to create different scenarios on how these products get closer to society. This is what we are. This is how the Fab chain looks today. Now we have actually we're going to share with all the participants the draft of the white paper of the Fab chain. It's kind of a joke because like we always talk about like a blockchain as something very technical and a lot of code, but actually we are kind of crafting these relationships between people, production means, information, and so on. And we want to discuss about that more in depth later on. So this is another video that I'm going to skip. This is some of the work we're doing in our master in Barcelona. Is related strictly with these topics. We have also a book that is called The Fab City, which you can actually, which we don't have stock, and you can order it and be manufactured on demand. I think the guys from MEKTORY and Peer-to-Peer Lab just ordered. I saw that you ordered 25 books of them. And then if you want to know more, you can get access to EAC, to Fab Lab, and the Fab City initiative to get to know more about this work. So this is a brief introduction of why this day, why it's important to have these discussions. I'm really glad to come in the room with people like Karen and like Tom, but also being able to discuss later on with people like Jamie Burke, which is the founder of Outlier Ventures, a big blockchain investment fund, Primavera de Filippi, which is a researcher in Harvard, and the Center for National Research in France, as well as Liz Corbin, which is now the research director at Metabolic and also founder of Materium. So with no more extension, I would like to welcome Tom to talk about the work they're doing in Wiki Factory and to show us in a very clear example what it looks like collaborative design and production. Thank you. Okay, so then we have, sorry, this is not on. Where did I have your file open? I have to open it. Okay, then I guess we move here, yeah. Yeah, okay, thanks.
So yeah, hi everyone. I'm Tom Solfield, the CEO of Wiki Factory. Thanks very much to Thomas and DDMP Fab Lab Barcelona for inviting me to speak here. Wiki Factory, we're developing a social design production platform. So all about the kinds of projects that Thomas has been talking about. How can we make it possible for people to work on these projects around the world and produce those projects in a distributed way, which turns out is harder than just sharing files. So a lot of our work has been around that and how it's possible to solve those problems. So we've been working on this platform for a couple of years, oh, how do I move this thing? I can't. Ah, okay, I'll do this one. So Wiki Factory, our vision is to enable a future where starting a product company is just as easy as it is to start a software company today. So we come from a software development background, and we use all these tools. For example, GitHub and Git, these version control systems, which make it possible for us to work asynchronously together. We have tools that then take our source code, compile it, run automated tests against it, and then automatically deploy it to servers. This is standard in the software development world today. What we're trying to do is make a similar kind of workflow available to product developers. If we look at the open source world today as well. In terms of software, we have all these reusable components. We have like the ability to deploy services, say to Amazon, very quickly at low cost. There's no upfront cost. So all you really need in order to start a software company is a bunch of talented people and a lot of hard work. But you don't need a lot of upfront investment in order to get a prototype out. If you contrast that with the world of product development today, it's changing because of digital fabrication. But prior to that, it would be a question of setting up a production line. You come up with a design. You maybe need to produce 50,000, invest a few $1 million in order to set up a factory. And when you do that, afterwards you're going to have to try and market that to someone. So we have this whole world of manipulative marketing to then try and sell products which have already been produced and a huge amount of money has gone into the investment of. Only after you get to market do you realize actually we can change this product. So obviously the world of digital fabrication has the possibility of making it possible for us to iterate continually, to produce and constantly produce and constantly upgrade the products as we're producing, amongst other things. So when we looked at how to try and create that kind of ecosystem, those kind of tools that are required in order to be able to go from design to production and produce in a distributed way, we kind of found that actually it's surprising how backward the world of computer-aided design is. It's a very conservative software industry compared to almost any other software industry out there. Partly because it's extremely complicated. So it's in a way maybe the last software industry that hasn't really been disrupted. Is still very desktop oriented. So this means that a lot of the data that's generated in a design process and the production process is not captured. And so, actually, if you ship these designs from around the world, it becomes extremely difficult to do what we call a reproducible build. Being able to actually take a file from one 3D printer to another and be able to do the same thing is extremely difficult given the current technology. And that's partly because we're not also in the maker movement. So in the kind of corporate world, they still have these problems because they use these PLM systems, which are very old style. In the open source world, we don't have these systems at all. So we're sharing STL files, typically on the internet, with regard to 3D printing at least. And those STL files really aren't source files. It's like me calling something open source when I'm actually sharing a binary. There's no way of going back from that STL to the original design software. And actually STLs include none of the information about how something's going to be produced. Even size information isn't there. Even the scale information is missing. So basically we started off with more the design problem, the collaborative design problem, and less the distributed production problem, which we're now beginning to tackle. So we spent last years really working on how can we create an online version control system that actually works for design. We know that a lot of people are using GitHub right now for designs, but we really don't think it's a suitable solution to the problem for various technical reasons. To make it a social site so that people can connect and actually find people that they want to work with online, and to create a system for high quality documentation of these projects, which right now we find there's no solution that just offers these basic tools. Also to work with these CAD formats. So just briefly show you the software we've built. So here's a project which was released open source. It's called Project North Star, and it was released by Leap Motion. It's an AR headset, which you're currently seeing the view looking through. where you can create these interfaces. It's got a hand tracking device, so you can create these kinds of beautiful augmented reality interfaces. The design of the headset is maybe a little crude compared to what you see with Magic Leap and HoloLens today, but pretty interesting project. So this is the documentation system which we've created, and it's using a thing called Markdown, which makes it version controllable as the underlying thing, but it's rich text kind of editor. I'm logged in not as myself, so I can't actually do that right now. And so then we have this version control system with the history and so on, and some basic project information. Here you can manage the settings and the kind of permissions and so on. Just try and change tab. So here's the 3D model shared in the web browser. And you can select these different components within it. So unlike with an STL file, you can actually see the structure and the different components of the design. So we'd be able to now sort of attach various like pieces of manufacturing information and so on to that. This is something that's not quite ready, but you should be able to, basically you select these components and then which materials, which machines am I going to use, what are the software services that we're going to use in order to process that file and turn it into something that can be produced. I can't use this trackpad very well. Other nice little things, you can sort of explode that and see how all the pieces fit together. So apart from these features, which took us a long time to get together, the main concept is it's a social site where people can collaborate, work together, find the people that they want to work with. So yeah, the next phase is very much around how do we take that, go from design to production. And I mean, this is a kind of theory of how it actually should look, the innovation and the kind of design process should look. So effectively being able to collaborate around the designs, download the designs and visualize them and so on. But also to be able to then take to use software services, which we're trying to create a platform for those software services because we won't be able to create all those software services ourselves. There's many different kinds of software services that are required when going from design to production with software that's called CAD to CAM software. And then there's also simulations, so it should be possible to simulate how these products work. So there's kind of a need to bring together the design community, the software community, and the manufacturing community. So once we, so these three, there's these three different kind of iteration cycles. First, changing the design. Second, integrating, i.e., building the software, and then finally, actually producing a build. So each of those three things can happen in parallel, in principle, and that's what we're trying to facilitate. So yeah, why do we want to create a scale-free production system? On-demand production is an important reason. One of the benefits of that is that we can produce one-off customized products, but also reduce inventory and costs. So again, it's about not having to invest a lot up front to start a product company. Another is that it enables actual distributed production. Right now, distributed production is not viable for the reason that there's usually a lot of human intervention involved. So if I want to send a new component to a 3D printer manufacturer or CNC shop, then I'm going to have to do quite a lot of work directly with that individual. So that means that each time I were to go out to a different CNC shop in a different country, that I'm going to have to do that process again. So we basically need to remove the human from the process of distributed manufacturing if we want it to actually be viable. Yeah, and finally, it's about circular economy. If we're producing in a distributed way, if we're producing locally, then it becomes viable for us to actually be taking the waste of these products and putting it right back into the machines to produce the same products. So, what are the barriers to scale-free production? I guess I've said it a few times already, but repeatable builds. There are reasons why we can't do repeatable builds. Traditional, professional product companies tell us that quality management in manufacturing is extremely hard. It seems to even be hard in digital fabrication, which seems kind of ridiculous. When the idea is it's digital, it should be a simple programming problem, right? But actually, it's even harder to do quality management in 3D printing than it is in traditional manufacturing today. And the production data isn't being captured because when we actually do that work, it's happening on the factory floor. Is the work to go from an STL, from a source file to the code that's actually going to drive the printer or that's actually going to drive the CNC machine is typically done on the factory floor or on a desktop machine. So when that happens, of course, the data is lost about what were the machine settings, what was the slicing settings, et cetera, et cetera. And so one of the things we want to do is make it possible for people to do that online and do that in a way where the data is captured. We use these settings and those settings. This particular build worked. This particular build didn't work with this particular printer, et cetera. So I think just now moving on to business models that are going to be enabled by this. There's some new possibilities of the kinds of business models that are going to become possible. So subscribing to a product as a service. For many years now, jet engines have been subscribed to by the airplane manufacturers. Rather than buying engines, they rent and subscribe to a certain amount of thrust, which is then taken care of by the producer. What this means is that they don't have to care about that, so that's one less concern. But it also means that there's a kind of alignment. So the interests of the producer are aligned with the interests of the consumer because they don't want to produce something that someone's going to have to replace. They want to produce something that's possible to maintain and to maintain it well. So I think that's interesting in terms of the potential of these kind of blockchain solutions and the kind of contracts we could be setting up. Yeah, it's possible to work out new forms of crowdfunding. There's like really a problem with crowdfunding today, which is people fund these projects and then they don't know what to do afterwards. They go to China, go find some factory. They don't know anything about these factories. They don't know how to engage with the culture or the people. They end up with low quality products. They end up producing products at the wrong price point compared to what they crowdfunded at. So this can be solved or at least mitigated by actually having the designs up front when that crowdfunding happens. And also there's the kind of process of scaling production. So when we start to scale production, it should be possible to plan out, for manufacturers to say, okay, if you produce at this kind of scale, this will be the cost for these components, and then you should be able to actually work out how you can reduce cost as you scale in a much more viable way once you have a kind of a supply chain which is transparent. And yeah, well, open source products and components going to be an interesting space. Reuse of open source products and components, I think, is in very, very early phases. Obviously, we've got things like Arduino, where people are using that, but I think we've got the opportunity to create much bigger library of open source components. And the question is going to be, what's the reward mechanism that we give to the content creators, and how do we structure that? So yeah, fundamentally, we come at this from a much more collaborative basis. We're a startup company, but we're interested in the kind of bigger picture and how we can. And the reason we are a startup company is in order to be able to get the resources to do this kind of work. So we're interested in how we can build a bigger ecosystem with Fab Labs and with all the organizations working in this space. What's important, it seems to me, is that we create an ecosystem. When we're talking about blockchain, we're talking about cryptocurrency and so on. We create an ecosystem which creates incentives for all of these three different groups, essentially. Those who are working together on products, those who are providing manufacturing services, but crucially, and I think people forget this, the software, which is going to facilitate going from design to production. I'm very excited to become part of that conversation. And yeah, so that's it from me. Yeah, an internet of production is where we think, it's the kind of way we think of it. If there's now the Internet of Things, we want to develop an internet of production, and we'll be very happy to talk to any of you about getting involved in that. Thanks.
Thank you, Tom. We are slightly delayed, and we're trying to figure out if I see Kate doing like this, what it means. We need to make a break. Okay, so we need to make a break of 50 minutes and then come back to start at 12:30 and connect with our speakers online. It's going to be a challenge for some of you to have lunch in 50 minutes. For us, it's okay because in Spain we have lunch like at 2 p.m. So let's do a 50-minute break. Let's restart at 12:30. We're going to set up everything here. Grab as many food as you can in that time, and see you 15 minutes. Okay, thanks.